Okay, I just want to show you some equations, solving equations. So they can come in a lot of different forms. Here we're going to be using more fractions in these equations. So just giving you more experience in solving these. This first one here has f plus 2 over 9 equals negative 15. And we want to solve for f. So our equation, we eventually want to say f equals some number. But if you notice here, f is a numerator in this fraction. So how are we going to do that? So one thing we can do, there's a few ways we can do this, but just building off of how we use proportions, how we cross multiply, we can do something like that where we, because this is one fraction, and then this is a fraction. If I put negative 15 over 1, I'm just going to put a dotted line here over 1. We can cross multiply. We can say f plus 2 times 1 equals 9 times negative 15. And that's one way to do it, so let's see how that works out. So again, I'm going to cross multiply. This is just one fraction equaling another fraction. That's why I can do this. If I had here f plus 2 over 9 plus 8 equals negative 15 over 1, yeah, I couldn't do that right away. I'd have to resolve it into just one fraction equaling another fraction. But here I do have one fraction equaling another fraction. I'm going to cross multiply. So I'm going to do f plus 2 times 1. So I'm going to write it like this. 1 times f plus 2 equals 9 times negative 15. 9 times 15 is 135. I have a positive and a negative multiplying, so it's going to be negative 135. Okay, and I'm going to use distributive property here. So 1 times the quantity, f plus 2. So 1 times f, remember distributive property, I'm going to multiply 1 by each term in this parentheses. So 1 times f is f plus 1 times 2 is 2, or 1 times anything is itself. And so now I've distributed this, and I can remove the parentheses, equals negative 135. And now I just need to get f by itself. So I have a plus 2 here. I'm going to do the inverse operation, so subtract 2 from both sides. And I'm going to get, this would be 0, so I'm going to have f equals, and negative 135 minus 2 is going to be negative 137. Okay, and if I go back and use this number in f, I would get something like this. I would get negative 137, that's for f, plus 2 divided by 9. Does that equal negative 15? And if I do that, I'd get negative 137 plus 2 is negative 135 divided by 9 is negative 15. That's correct. And I check my work. Okay, let's take a look at this equation up here. It's going to be 14 plus 3/7 z equals 17. So my variable in this equation is z. And right now it's being multiplied by 3/7. We also have a positive 14 here on this side. So we want to resolve all these things so that eventually we'll get z equals some value. We want to isolate the variable. Okay, so the first thing I'm going to do here, I'm going to try to resolve this positive 14. So I'm going to subtract 14 from both sides. And what I get from that is 0, so I'll get here 3/7 z equals 3. 3/7 z equals 3. Now, in order for me to resolve this, notice 3/7 times z equals 3. So What I have to do here is I'm going to just do the reciprocal of 3/7, which is the 7/3. And I'm going to multiply both sides by 7/3. Remember, whatever I do to one side of the equation, I have to do the other. So if I multiply these two fractions, I'm going to get 7 times 3 is 21. 3 times 7 is 21. Z equals, and then here we're going to have 7 times, you can think of this as 3 over 1. So 3 times 7 is 21 over, and then this is going to be 3. Okay. And so this is 21 over 21 is just 1. 1 times z is z equals 7. And that's my answer. And if I put that back into the equation, I'd get 14 plus 3/7 times 7, which is what where z is, equals 17. And I'd get here 14 plus, and again, this is, you can think of this as 7 over 1. So if I multiply these fractions, it would be 21 over 7, which is 3, equals 17. And that is correct.